afternoon, everyone. So I've already introduced myself through Andre there, so I'll get cracking. I'm here to talk to you about infrastructure automation with Puppet. So I've already had the pleasure of meeting a bunch of you today. I've spoken about a bunch of topics, but here are some of the kind of recurrent themes which keep coming up. People talking about doing things faster, people talking about doing things more reliably, in a more repeatable way. In fact, before I continue, can I just ask who's running their applications on platforms which are manually configured by someone, by a person? Great. And in some way scripted, or through imaging or something else like that? Great. And who's using configuration management of some sort? Great. You can all go. The rest of you can stay. No. So, these are the recurrent themes which keep coming up. It's about doing things faster, it's about doing things more reliably by having a kind of more homogeneous platform, about having a known configuration out there and really knowing when things are out of place. And this is a problem that's going to, it's not going to go away. There are basically more servers in everyone's future. There are more systems that are going to need to be configured. There are going to be more complexity out there to be managed. And I don't see much increase in spend going around, so we're just going to have better ways and smarter ways of doing things in order to manage the platforms our applications run on. So this is kind of the state of the union, well, at least for those of you not using configuration management right now. For many of you, you'll be running some scripting, some automation, which is a good thing. There'll probably be a bunch of Bash or Python or Ruby or Perl or some sort of scripting going on after the setup of the provisioning of your virtual machines for your applications that will take it from sort of known point A to known point B quickly, just by chaining a bunch of tasks, a bunch of configuration tasks. And that's good, that gets things done faster than it would have been done by a person, certainly, and probably more reliably. But they are kind of fragile. You take them out of that one particular context and they won't work as well, or they won't work at all. You try and use on a different operating system and they won't work. They're not portable. Again, as well, if you ever tried reading someone else's scripts, they're often widely deployed but not often widely understood by the organization that they're running in. They might not be well documented, etc. So that you have a kind of very tailor-made approach there that isn't easily supported or is somewhat fragile. At the other end of the scale, you've got large automation or systems management software with well supported by big enterprise companies, but may not be well tailored to your particular organization and or your particular needs. So they might do way more than you need it to do, or they might not do enough of what you need it to do, and you don't really have, there's not a lot you can do about that. So Puppet really kind of takes a lot of the benefits of both of these approaches. So Puppet is it's actually a language, so things are written in clear text, and you get lots of the benefits of that. So it's readable, it's editable, you can use it with version control, and it fits into a lot of the kind of practices that people have been talking about today. But also, of course, it's got a company behind it. It's a well-resourced open source project. This is a little bit about how Puppet works, and this is kind of the important slide. So pay attention for this one if you're gonna switch off. This is really about how Puppet runs. Okay, so instead of having a list of tasks, a list of things to do, a procedure, if you like, Puppet is really about defining the end state for a set of resources on a system. So we're no longer saying create this user, copy this file, install this package. We're saying this user is there. This service is running. This package is already installed and at this version. And Puppet takes care of the rest. So there is a software component that basically is able to model the configuration and introspect the way that it is right now, running on the system. And it's able to compare that to the way that you want it to be, the way that you've defined it. And as you can see, it's kind of human readable. There is a syntax to it. It's a DSL, a domain-specific language, but it is something that someone can read and infer what the purpose of it is. Now, because we have this ability to talk about end state, and because Puppet can understand and reconcile the differences in end state, we can go through this cycle here represented on this slide. So we define what we want, and this is just a very simplistic example, this is just one example, of one resource, the SSH service. And then we can compare it to the existing state by simulating a run. So we can simply say, here is a node out there in the environment, here's my desired state, can you compare the two and tell me what you would need to do to enforce this state? Now this is just for one resource, but it could be literally thousands, and it can come back to you and say, these are all the things that I would need to do in order to configure your desired end state on the system. And that's really good in a change management context. I've been speaking to people today who've got a whole bunch of different servers that have been deployed by different teams over time, and in different environments or after a merger or something like that, and you don't really sure what the end state of those systems are. So you can point Puppet at a bunch of different systems and it'll tell you what in each individual case it's going to need to do to reconcile the differences. If you're happy with that, if you're happy with what it's about to do, you can go ahead and enforce that state. So it will take it to the desired state from where it is. So this is useful when we're talking about like ephemeral systems, like the ones which are created as part of a build pipeline or are used in just a development context, from taking it from a bare metal server or a newly provisioned system all the way through to a completely functioning application. And that's great on day 0, but then we're talking also about its lifetime in production. If you're talking about 2 years hence, what is the state of a system 2 years hence? Puppet is always checking in some way, in a master and agent setup, where the agent is checking in with a centralized repository of these definitions. So Puppet will be checking in by default every half an hour and making sure that every resource under management is exactly the way that it should be. At the end of every Puppet run, it's going to send a report to the centralized master as well to report on all of those changes. So every resource under management the state of that is reported, and anything that went wrong can be acted upon and stored for posterity. Right, I'm going to do, while holding a mic, a bit of a demo here, bit of a dangerous thing. So here's my master system here. I've kind of got, I'm logged into the same host twice, just to give you a side-by-side look here. And I'm going to work with Puppet interactively just on one system, without introducing any sophistication of having like a master agent set up just yet. I'm going to come to that. So I'm going to ask Puppet to tell me about the root user on this system. So this could be root user, could be any user, but this is how Puppet returns the root user on the system. So it's basically made up of a type. This is a user, and this is the instance of that type. It's the root user. And we have a bunch of key value pairs, a bunch of attributes associated with that particular user. Okay, and that's all valid Puppet code. In fact, I can just pipe that out to file here by typing badly. And then that is a Puppet manifest. It's ready to be used. Okay, so I'm going to change an attribute about this user. So we're really just talking about handling one single resource. I'm going to just change the user's logon shell. Okay, but this could be any attribute of the resource on a system. So nice and easy, one command that I'm doing interactively. And that shell's changed. So I can run again, I can ask it to introspect the system one more time. So I've got captured in that file now the way that it was a moment ago with bash as the shell. And now I'm going to run it again. And now we can see that Puppet is able to introspect the configuration, look at that one object, look at its attributes, and see now that it's different. Okay, so it's found the difference. That's fine. Now, but I've captured the way it used to be, and that's a valid Puppet manifest. So I can actually run this against this system here. So I can say Puppet apply that configuration, and I can apply this flag here, no op. Now, no op is the simulation mode I was talking about. Okay, so I can say, let's run Puppet against this particular system. It's noticed that it is currently, it's actually gone off the screen. Let me expand it. But it's saying that its current value is binsh and it should be bin bash. Okay, so it's noticed that one difference. If I'm happy with that change I want it to make, I can actually have it run and enforce that change for me. And Puppet has actually changed that back, okay? So I had the recorded desired state, I had it look at the current state, and I had it reconcile the difference. Okay, and I can just run this over and over. This is not like a script that you might have to worry about state This is what we call idempotent code, which means that you can run it repeatedly and generally already get the same result. Everyone with me? Oh, where am I? Okay, cool. So one slightly more complex example now. Okay, so that was one resource and one attribute of one resource on a system. Now, this is how we could describe several resources as a group and define them as a group. This is how we assemble something called a class. So we have a single package that's going to be installed. We don't say install it, we say it is installed, and if it isn't, deal with it. We have a file that handles the configuration of that particular service and its permissions. And if it's not there, Puppet's going to serve it the file. And we also have the service itself that should be running. I think this was in the example before. But this has all been wrapped up into a single thing called a class, and that's what we apply to a host. You apply a class to a host, and then it will actually go away and add all of those individual resources and manage them for you. And also here, I just want to highlight, we're actually adding the relationship between these resources. Here, this one is being done before the config file. Makes sense to install the package before you configure it. And the service has been subscribed to the file as well. So if the file changes, if the config file changes, let's refresh the service so the changes can take effect. And that was a collection of resources there. So you can see how we're starting to build up the picture of readily running services. And here, these are all kind of base build configuration examples. But we can do the same for application code. We can do it for middleware. Okay? We can start to assemble Puppet modules, which start off as a kind of a single unit, let's say. This is a Puppet module, which is a collection of these manifests I've been showing you. And this one is handling the installation of Apache. Now, you can assemble that together with other layers of the stack, and this could be assemble a LAMP stack, so PHP, MySQL, your application even, and then you have the definition of a group of configurations that can be mapped to one system or a group of systems. Once you have it all set up, you can apply it to as many systems as you like. Now, you saw that there was a bit of coding going on there, and it is pretty straightforward. But we do have some software here that, like, for the developers here, that kind of makes it easy for you to adopt. If you're an Eclipse user, then you can add in a Puppet snap-in. It's called Geppetto. It's a Puppet reference. And it basically gives you all the kind of amenities you'd be used to in an IDE, so syntax highlighting and error correction, etc. It's definitely worth a look. It helps you to really get started, and whether or not you're a developer, in fact, because you just, you miss a semicolon or you miss a comma, it's going to tell you so. And even if, even if configuring your entire stack sounds daunting, we do have plenty of ready-made modules. So Puppet has a Puppet module Forge. There's 2,500 nearly modules up on there at the moment. And we've got a lot of the standard stuff has already been done. A lot of the difficult work has already been done. So a lot of the standard middleware, utilities, across operating systems as well, have been shared and for open source use. Indeed, on top of that, we have a group of supported modules, which Puppet Enterprise will support for its customers. We're actually adding in another one, I think yesterday or today, which is for VCS repo. So basically, we're supporting the module that handles the pulling in of code from a Git or a Subversion repository. We also have support, incidentally, for network and storage devices. It's no longer just about operating systems. So we do have a program that's just kind of just started and been announced, I think, just an hour or so ago, whereby we have support, Puppet-supported vendors, so Cisco and Arista and Huawei. So it's no longer just about the OS. You can actually configure the wider infrastructure, storage, network, and compute. So this is probably the most more technical slide, but this, all I really wanted to show here is what happens during a Puppet run and show each of the components that are actually in Puppet, just so you can give you an idea of the process. So I was showing you before how Puppet runs when you're working with it interactively. I was sitting on one host and working with the individual resources of that host and capturing it into a file on that host. Really, when you deploy it in a larger scale environment, you'll be running it in an agent master setup. So you'll have a centralized master, which performs this role of holding all of the Puppet modules, which is Puppet code, and as such can be stored well, and you can benefit from all of the the benefits of having it stored in version control. So it's a centralized file resource for Puppet modules. It also allows for all of those great sort of collaboration practices that people use. And then you can install the Puppet agent on all of your systems to be managed. That's Windows, different flavors of commercial Unix, various flavors of Linux as well. And that will check in with the Puppet master. So the process as it happens is that like the Puppet master will run and it will be invoked in some way. That can be done across the network using the orchestration component mcollective, which will be useful, for example, in a Jenkins build pipeline. It can be invoked interactively, as you saw when I was working with Puppet on the command line then. Again, Puppet, Jenkins can invoke it in that way too. So it builds an inventory of the system, sends that to the master. The master uses that to identify the system and decide which classes. If you remember, I was showing you which, the class before as being a container for managed resources, which ones should actually be applied to that system. It gets the response to that. The master itself will compile what's called a catalog. The catalog is the desired end state for that system at that point in time. And then that gets sent back to the agent, and the agent works on applying that config. And last of all, the report gets sent back up to the master for long-term storage. That is basically what happens during a Puppet run. So you saw there was a bunch of components at play there. These are all kind of packaged together in Puppet Enterprise. If you install them all individually, there's a degree of integration to get the backend database, for example, hooked in. And we vendor all of that as Puppet Enterprise. It's a single validated stack that we provide. It's got an easy installer. We're really just trying to lower the bar for entry for people so that people can get to the value of this kind of technology as quickly as possible. There's also some extra functionality in there. I'm going to use the graphical user interface to save me typing in a minute. But we also have support around all of that, including the supported modules. And the whole stack is QA'd. So it's not actually just Puppet that we QA and look after for you. It's actually the underlying Ruby. It's the underlying database software, etc. We're monitoring all of that for you, including OpenSSL, incidentally. And here's another representation of it. Really, you have that master that can take in content from the forge. You have all these agents checking in. Those can be on different platforms. They can be devices too. And Puppet is highly extensible. There's various points during that process that was on that slide a few moments ago where you can hook into third-party systems. So, for example, you can act on a report that's come in that says some resources are non-compliant, and you can raise a ticket, or you can send a mail, or you can write to a log, or something like that. And if anything has failed, or a bad exit code, or anything else like that, that information indeed can be used by Jenkins in order to fail a test for building the underlying infrastructure for the applications you're using. Okay, let's deploy an app. I'm going to whiz over to Puppet Enterprise here. Hopefully I'm still logged in. I am. Good. So this is the Enterprise console. I'm just going to use this to configure a couple of nodes. The main two, I would say, areas of functionality for this console is classification, which is what I'm going to do now. I'm going to set up a node, and reporting. So you can actually see what's happened every time Puppet runs. So we're going to go and fish out some classes that are already on my master here. Add some classes. Okay, good. And let's put some Tomcat on there. And let's pick out an application, war file based or something like that. Let's put on Jenkins. Why not? Given we're here. And those have been added to my console. I can now make use of them. I'm going to make a group out of them so I can deploy them all as a stack, just for deploying Jenkins. And those made up of Tomcat. And it's made up of Jenkins as well. Okay, and I'm going to add a node into there. That front page I had open a second ago is like 9, 10 nodes that are running on my Mac here across different platforms. I'm just going to add it to a CentOS node that I've got ready here, ready to be done. Okay, and I'll create that now. So this is the group. It's made up of the configuration for Tomcat and Jenkins. I've associated it with a single node. This node is pretty much vanilla. It's got nothing but a Puppet agent on there, really. If I whiz back over to my console, I could invoke this via the GUI, but it's worth seeing kind of what's happening. This is the kind of thing you can invoke from a Jenkins CI server in order to kick off the configuration of a node, for example. So I'm using the mcollective component. Okay, so that's there on the left. That just basically said, go and run Puppet on that node, please. And on the right-hand side here, this is the syslog of that server starting to run now. So I've reached out across the network, invoked Puppet. Puppet's checked in with the master's calculated its catalog, sent it back, and now that agent's actually working on getting it done. So it's not going to be done yet, and just to prove I'm not got anything up my sleeve here, you'll see that Tomcat isn't running yet. That's going to fail. So we'll come back to that shortly. That's going to take a few minutes to run. Okay, so that's deploying. Just a bit of backstory. So Puppet was an open source, is an open source project. But it was started as an open source project purely in around 2005 by our now CEO Luke Knies. We're now in 2014, so Puppet's in version 3.6 something. Puppet Enterprise was first released in Puppet 2011, and we're now in version 3.2. Last week we got another 40 million in funding. So and that's everyone from our previous investors has gone back in. So that's we've got some strong integration with VMware that's just going to keep getting stronger. Cisco indeed have put a Puppet agent on their Nexus line of switches. So the kind of our reach out into other vendors and into the industry is just increasing. So Puppet's a good thing to learn if you're a systems administrator. I don't know if any of you are, but there's a lot of demand for these skills, as you can see. Hopefully you can see kind of the potential now for this style of managing systems, it being about managing the config all of the time, rather than it being just about setup and just about provisioning. And we have a vibrant community. This is like my third time in Germany in a couple of months. My counterpart is in Stuttgart today at DevOps Days. So there is just a ton of activity in this space. So yeah, just to underscore the connections we now have, building out our Puppet supported, what's it called, a program. This means that these vendors can now say that, Puppet Enterprise customers, we have a cooperative support agreement to manage Nexus switches, NetApp filers, etc. with Puppet. That was just announced today, so expect the Twitters to blow up about that. Here's a bunch of people that are using us. Shameless plug, I know, but the initial kind of uptake of this kind of technology started off in the technology space. It was in the internet space, and it was in finance, all the places you'd expect to be the early adopters. But now these days, we're now really talking about anyone having systems who has systems to manage. It's now that much easier to use. It's now that easy to adopt thanks to the development of all of the constituent projects. Puppet Enterprise makes it easy, and you've got people like me talking to you about it. Where's that? Oh, here we go. Beg your pardon. Okay, so let's bring it back to continuous delivery a little bit here. So if Puppet's just involved in setting up servers, clearly then there's a strong use case in a continuous delivery context. Okay, because we are checking in Puppet code into a version control system, just like your app, we can perform automated deployment of that, just like your app, and perform automated testing of its results, just like your app, in a build pipeline. So here in this example here, this is really about having Puppet doing the management of the server from base build all the way up to being ready to use your app, and then of course your app being deployed on top of that. But a lot of the same principles apply. You can simply have the framework built such that when you commit into Git or into Git, for example, you'll have a hook that checks your Puppet code for valid syntax. Then it will run a batch of tests against the catalog that would be generated by it in order to make sure that that is valid. It actually produces the result for the configuration you want on those systems. And then maybe even to acceptance testing to the point where it will actually start up a virtual machine, apply the configuration, and test that the actual result is there. So you can have that happen as a result of a commit into Puppet code, just as you can with your application code. And then you'll have a full delivery pipeline that handles both your application and the underlying infrastructure, which becomes extremely powerful. You can imagine someone, a developer, for example, checking out the Puppet code for a system and running it on their laptop in order to build a development virtual machine. But that will be the same Puppet code that's being used to build the virtual machines in the the actual development environment and the QA environment and production as well. And this just improves the confidence you can have that your software is going to work across environments. So just to call out a few of the utils here, I know that some people here are already using Puppet. So these are some of the tools that you can make use of. Puppet, the lint testing side, you have actually built-in parser validation for Puppet to make sure everything's fine. So you might use this in with a Git hook even, or just as when you're working on things interactively when you're developing it. So running Puppet parser validate will just make sanity check to make sure no errors are generated just by looking at your code. And then Puppet lint will actually look at your code against the style guide and make sure you're using spacing instead of tabs and all that sort of thing. So you can have a git commit be refused, for example, if things aren't 80 characters wide like they should be apparently. And then further from that, it's the more sophisticated side, the unit testing. You've got the catalogs that are going to be generated to send down to an agent to configure that. That can be actually tested to make sure it includes the resources that you defined. So, okay, my Puppet code says that it should have a particular service running, or it should have this middleware installed. Is the catalog that's being sent to a node, does that actually contain that resource? And Aspect Puppet will help with that. And finally, Beaker. We had a picture of Beaker a moment ago. I love that character. We actually have a meeting room at Puppet called Beaker. And this is the project. It's actually been developed by some of the guys at Puppet. It is an open source project. It's hosted on GitHub. And this is the one that actually goes ahead and builds a virtual machine, pushes the configuration down to it, and then asks, is this port listening? Is this software really installed? It's the full acceptance test. And from that, you can have a very high degree of confidence in that what's going to move forward into production is the real deal. So just the last couple of slides here, I just want to call out some resources if anyone wants to kind of pick this up. There's Puppet put an enormous amount of effort into making this stuff easy to learn and throwing kind of loads of education resources out there on the net. So puppetlabs.com/learn. There's a bunch of videos on there. There are tons of documentation. There is a learning virtual machine that you can download with a PDF with things to work through that basically help you assemble a progressively more sophisticated configuration. And we provide training as well. We do have training in several of the main cities in Europe on pretty much a monthly basis. So you can get everyone training from the basics of writing fundamentals, the fundamentals of Puppet code, all the way up to Puppet architecture, infrastructure architecture, and indeed Aspect testing and Beaker testing. And there's its certification as well. And we have partners out here in Germany. We work with Netways to sometimes deliver training and some of the services around that. So we are local. And there are just a ton of resources out there, both books, blogs, sites, and everything else. So I'd like to just finish by returning here. And Tomcat did run, thank goodness for that. That would have been embarrassing. And then last but not least, all right, we got Jenkins stood up. Okay, well, that's my presentation done. Are there any questions from anyone? It's been a long day, hasn't it? Okay, well, I'll be around outside if anyone has any questions. Do you have one? Go ahead. Yeah, sure.
Before we answer that question, this is the Q&A portion of the program. So any final questions that you have, now's the time to ask them. In fact, I'm going to ask all the speakers if they would come up front, and we can just handle any question that you may have that's still lingering in your mind from today's program. So I'll let you answer that question as the other speakers come up front.
Okay, go ahead.